So I hope you have had a nice week here, and I will start with introducing myself. My name is Martijn Bellet. I'm from the Netherlands, and I work at a company called Wortel, and my job there is to be a strategy consultant. I'm also on Forefront MVP. I try to blog and try to share my knowledge about Forefront products like TeamG and Forefront endpoint protection with other people. And I have what I call a side activity, and that's IPv6. It starts somewhere, for me, in the NT4 period. I found some dark site on the Microsoft website, some downloadable IPv6 stack, and started installing it and said, what's this? And from there I started investigating what IPv6 is and got to know it. In 2008 somebody asked me to write a book about it. So I decided to write a book about it. The bad news for you, it's in Dutch. Oh, sorry. I'm working on a translation, so I hope to have a translation next year. I'm also blogging, and you can find me on Twitter. I always like to start with a few questions. So my first question to you is, does anybody know what 0 means? I think the gentleman in front does it. Yes? It's a high, no, I will give you the clue. That's the total number of IP4 address the ENA has at this moment. 0, none. So they're out. And I always try, if I explain this, is look at it as a river, you know. And this river of IP4 numbers was flowing and flowing all the years, and now the source is empty. So if you go up to the mountains and visit IANA and you look at the source, there are no more IP4 numbers there. And if you go down the river, you probably find some IP4 numbers. You are sitting at the end. So you probably have still some water running around you, but it's coming. You know, go to the other river. There's more water there. It's called IPv6. Anybody have a clue what this number means? Yeah, number of IPv6 numbers, very great. It's a huge number. On my last slide, I actually written it down how you can pronounce it, just for the fun of it. Okay, and for me it's always nice to know, because it's a 400 session. Is anyone play with IPv6 here? Please stand up. Yeah, I see some people actually standing up, great. This is a 400 session, so I won't go into the basic stuff of IPv6. I will just try to focus me on the migration, how to go to IPv6, the steps you can take, and the issues you get. This is the agenda for today. I will first discuss 5 steps you can take to go to IPv6. And then I will go take those 5 steps on a demo environment I've built, and I will use the Windows operating system, and I will go demo 2 applications, just to give you some hands-on, okay, how can I go and migrate my applications? And I will talk about some problems you can run in today or in the future, and just to give you some guidelines. But first, let's down to the 5 steps. The first step you have to take is starting designing your IPv6 environment. What probably will happen is you get a /48, or if you are a bigger company, a /32. I put down an example, 2001 131.0.1969. Just an example. It's probably something like that you will get from your ISP. So that will be your global IPv6 range. What you can do with it, well, a host ID is 64 bits. I will get later in why it is, but it's 64 bits. They made it, they said, okay, let's reserve the last 64 bits for the host ID. So from 48 to 64, you can actually go around and building subnets, around 60,000 subnets. To keep in mind, if you get an A-class IP4 number, you can make the same amount of subnets. Just imagine that much amount of numbers you get. And to get you an idea, I have IPv6 running at home, and I get a /48 for my home. So I give my couch, can I give an own subnet, and my TV can I give a subnet, and it's crazy. But that's actually what happens. And what you can do with subnets, because there's a lot of things. We are used in the IP4 world to say, okay, let's be careful with our numbers. So 1 to 10 is for this, and 11 to 12. Don't do that in IPv6. Go think different. Well, a very easy thing, you say, okay, I got just one location, with some VLANs on it, just go and put the VLAN on the ID. Like I did here in the first example. 001 would be the first VLAN, 002 would be the second VLAN, and you can continue from there. Or if you have like multiple locations, you can say, okay, let's do some location code. And what I did here, I took the zip code from Atlanta and translated it to hex and put it in it. So it's actually readable. So this number tells me, okay, this is Atlanta. This is my Atlanta location. There's a lot of things you can do with this number because you have plenty of it. Try to use that. We wouldn't do that in IP4 world. We probably would say, okay, 1 is Atlanta and 2 is. So different way of thinking. Okay, I talked about subnets, but we also have numbers. You have 64 bits to give out a number to a host. You can give more numbers in one subnet than there are on the internet today. So you can actually host every server on the internet, including all Google servers, all Microsoft servers, put them in one VLAN at your location and give them all a number, an IPv6 number. And still have number left over to do more things. So you have a lot of numbers. So don't start doing what you do with IP4, go from 1 to 10, and from 11 to 20, but take another approach. In some examples I give here, I say, okay, all my servers will be A, and I put it at the last one, the second last one spot. I say, if it's an A there, it's a server. And then server 001, I will put down 001. So if I see A001 or A002, I know this is a number from a server. Makes it easy to read. Or if in the case of a router, all routers have B. There's some guidelines. But the first thing you have to discuss with you probably have some naming convention for your service. So take that naming convention and try to translate to IPv6 so that the number makes sense. The number has some connection to the name. Okay. And then we're going to look at how you're going to route the traffic over a network. And keep in mind, you get a global range. This is new for us. Most of us use a private. Who use a private range for the IP address internal? Most of us will. So what I notice if I talk about people about IPv6, they say, oh, I get a global range. Oh, that's scary. Because I have a NAT device now that protects me. Well, NAT is not security. It's just address translation. Your firewall is security. So make sure you have the right firewall up and just route in the range internally. No problem with that. It will actually save you a lot of issues. Okay, the second thing is we got those nice protocols. ISATAP, Teredo, 64, you've probably heard of it. And I have to tell you something about these protocols. The people designing IPv6 are not the people that are sitting here, not the people that are working day to day in a network. But they are sitting somewhere in a university and thinking about how we have to go around with this number. And they say, oh, listen, when we start designing IPv6, companies will start using it. And they will have like this IP4 only networks, or they have to go over the internet because the ISP is not on the IPv6. Yeah, well, let's get back down to real business. Who's waiting for the ISP to go to IPv6? I think that most of you are waiting for it. So the use of these protocols are not really that big. Even there's a talk about that 624 and Teredo, if you use them to route IPv6, you notice a decrease in performance. So if you go native IP4, it will be faster than going through these tunnels. So explain that to your users. Yeah, we use a new protocol, and you are slower if you access a website. That's a bad story. An ISATAP is used for the private lands. So if you have a private network with private IP addresses, you can use ISATAP. Now, most of you probably have designed some sort of VLAN, and you've made multiple VLANs and put routers between them and switches, and think about how to control your own traffic, and then you can use ISATAP and run tunnels all over this network and actually going to make one big network. Well, that doesn't make sense. So these protocols aren't really useful. Only if you use like direct access, Teredo and 64 makes sense. Okay, so use these protocols, don't use them, just go native IPv6, just start routing, just making your routers doing IPv6. And control your network, actually you control IP4. And then we got this story about prefix discovery. In IP4 world, we use that the DHCP server actually giving out the number. The client boots, goes to the DHCP server and asks for a number. In IPv6 world, they said, let's make the host his own number. So the host creates his own host ID, and all he needs is a prefix. What's my prefix? And there are two options you have. You can go to DHCP v6, and you can say, okay, let him handle out the prefix to the client, or you can go to your router. And the best thing is going to your router. Keep in mind, the moment the client boots, the first thing he will hit is your router. It will not be the DHCP server, it will be the router. So let the router actually start giving out this prefix to the client and let him do all the jobs. So this is the other things you have to do if you start designing. How do you go around my IP numbers, how do I go around with my subnets, and how do I go around with prefix discovery and routing and all that sort of stuff. But some general guidelines. Keep it simple. It's a hex number, so they can be pretty complex. And I know a lot of people like, okay, I'm scared. I know my IP4 numbers, but I don't think I will remember my IPv6 numbers. I will promise you, you will remember them if you keep it simple. Just make a simple design. Design it for growth. With IP4, we didn't have that much numbers, so we always try to be, safe on the IP numbers. You have a lot of numbers, so if you design it from a location, just hand out too much. Then you can grow on that location. And work with /48, /52, /56, 60, or 64. Means you work with nice cuts, and you don't have to calculate. If you see a number, you have to take your calculator out and say, oh, which subnet is this? Now you can see it straight away. So we like to work with whole parts. The second thing we have to go, if you have made your design, and that's what I normally do at the customer side, is doing an IPv6 readiness check. How far is your environment IPv6 ready? And the first thing I look at is the network devices, because they are on the bottom. And not only the routers and the switches, I also look at all those devices like cameras and other stuff that's on the network. That's not an operating system, that's not a user device, that's not a server, but it's connected to the network. And the second thing I will look at is my operating systems. Which operating systems do I run at this moment? And do they understand IPv6? And these things probably won't be the hardest to check. And then we go down, that really will be hard for you checking this your applications. And I will go into deeper here because application actually gives you a lot of issue. For the first two, there is this website, IPv6ready.org. And they have invented this logo. You ever seen it? It's the gold logo. There was also a silver logo, but they don't hand it out anymore. This is what they call phase 2. It actually means if a device or an operating system gets this logo, it's completely ready for IPv6. Completely. And you can use it. There's a big test they have to go through, and if they pass this test, they get this logo. So this can help you. Go to this website, look up your devices, look up your operating systems. They have a nice creator in it. You can go down it and find your operating systems and network devices. Okay, the second thing you start to do is testing. Testing your network devices, testing your operating system, testing your applications, and don't forget to do a user test. What I normally like to do is sitting in a user, if I do some sort of migration, design a new desktop, what I normally like to do is put a user behind the desktop and say, okay, go work like you normally do. In this case, I would probably disable IP4, just go into the properties and hit the thing and just say, oh, just disable IP4. Keep in mind, if you do that, inform your user that internet probably won't work. They can go to Google, but if they try to find any other website, they probably fail. Inform them in front. And let them do the test and figure out what goes wrong. And then turn on IP4 again and start to solve the problems. And then we're actually getting to do a stack mode. And this is very important. I notice if I talk about IPv6 and the migration to IPv6, and a lot of people are afraid they have to go in one phase. So disable IP4 and go to IP6. No, you don't. You will run dual stack. And I will promise you, you'll probably do that for 10 years. And this is not new. Keep in mind, back in the last century, there was like EPX, SPX, NetUI, TCP/IP, IP networks. We also had AppleTalk and DLC running on. That 5 protocols running on the network. So everybody longer than 10 years in IT probably have known that time. You have like 3, 4, 5 protocols running on your network. And there were issues then. Like a client A can hit the application very fast, and client B is very slow, and then you find out you have to do something with the binding. Okay, I promise you, these problems will arise again. It's one of the things you will notice if you go dual stack. But it's just what it will be is you will use both address. You will use an IPv6 address, and you will use an IP4 address. And I hope there will be one day we're actually going to say bye-bye IP4. And to be honest, I'm around 40 years old now, and I think I was probably around 70, and I'd be probably one of the last old guys still knowing IP4. You know, they rent me for a lot of money because I know IP4. So I think it will be very long. If you look at hospitals, they buy those big machines to scan you. They cost millions. They connect to the network. Guess what they're talking? It's not IPv6. It's IP4. Okay, this is about the migration, and I like to go in and actually start showing you some things how to do it with some real stuff. And the first thing I like to go is going to the Windows operating system. The steps I have to take is I have to design my network, I have to check it's IPv6 ready, I have to do some stack testing, and I will go to dual stack. I will not do step 5 in my demo. I will not say bye-bye to IP4 because I don't think that is something you will do today. That will probably be done in 5 or 10 years from now. Okay, this is my demo environment. It's based on the test lab guides Microsoft wrote. You can download them, and I based it on it, and I added a TeamG to it, and I added a Change server to it. But basically, I have an IS server, which is sitting on the outside, which is my ISP also. Then I got an Edge, which is some kind of router. I use Windows for this. I got a TeamG and an internal network. I got Windows 7, a domain controller, and Exchange. Okay, all right, so this is what I get from my ISP. And I told you I'm like 40 years old, and if you're very smart, you probably can guess my birthday. So what I decided, I go for a /64. Just go all the way down. And since I have only one VLAN, I use 1. I don't use 0 because then both two numbers will be the same. So I use 1. I know that it's the subnet. I would have decided to use my router for advertising or for the prefix, and DHCP for DNS and the IP number of the DNS server. So my network is looking. And this is actually what you probably will see in real life. Your ISP probably has some /64 subnet which you connected to. That will be your internal network, and your /64 or your 48 is your complete internal network. Okay. Step 2 is start checking my readiness. And I actually went to the website I was talking about, and I punched in Microsoft, enter, and give me everything from Microsoft. And this is a nice list. If you very good look, these are all operating systems from Microsoft tested, and we will miss Windows XP on it. Keep in mind, Windows XP does understand IPv6, but it's never been tested. And if you actually look at it, it's still a beta protocol on XP. Windows 2003 is the first server actually been tested, but it's phase 1. Means it does understand IPv6, but doesn't know really what to do with it. Something like that. So, okay, I can give it an IP number, but don't ask me too much, because I will get lost. And then we go down to Vista, and Vista is actually the first operating that gets up to phase 2. and then we see Windows 2008 and Windows 7. Means all those operating systems are IPv6 capable. They understand IPv6 and they know what to do with it. So let's look into that. But what does this mean? It does understand IPv6. Well, it's phase 2 ready, I've seen that. It understands IPv6. Very important, it understands neighbor discovery protocol for IPv6. It knows how to get the prefix, it knows how to hand out the prefix. It actually has a DHCP-v6 client on it, which you won't find on Windows XP. And it understands ICMP v6 completely, all parts of it. So I can do router discovery, router advertising, neighborhood discovery, neighborhood advertising, and all that stuff that's in neighborhood discovery protocol. And also very important, it supports IPsec for IPv6. And if we look at the server side, we see that it has a DHCP-v6 services. So you actually can hand out the prefix. You can tell the clients what the DNS server is or what the service is. And DNS supports the Control-A record and the IPv6 reverse lookups on it. So you actually can run completely IPv6 on it. Okay, I want to go into some technical detail about IPv6, how they thought about how you want to get a number and how Microsoft is doing it. The whole idea around this story was, well, let's use the MAC address. And that makes sense, because we know one thing about the MAC address, it's somehow unique. Every host has a unique MAC address. If you have two same MAC addresses on your network, you run into some very strange problems. So all hosts have a unique MAC address. And the second thing they were thinking about, let's make a bigger MAC address. They were 40 bits, let's make it 64 bits, because there will be more computers, so we probably need more MAC address. And then they said, oh, but then we run into problems, because we want to have a 64 address, but we have 40 bits. So let's transform those 40 bits into 64. And that's actually what's happening here. What they do, they cut down the MAC address into two pieces, put some FFE in between it, and they flip a bit. And they flip the bit because it's actually saying, okay, this we made by process. It's not made by the administrator. We did this by process. And we get what we see at the bottom, an IPv6 number. An FA80, I've sent it in front because FA80 is what we call the link local, only works on the link. So that's why you probably have seen that address in your Windows computer if you run ipconfig. It's a link local address. It's automatically given. And it means the host uses this address to communicate over the link to the router, to any other host on that link. It will not go over the router with this address. And because he has an address now made up, he actually can go for finding out his prefix. So we use this address and then say, okay, I got my host ID now. Let's find out my prefix and create what we call a global address. And, well, we had those two options in the router or DHCP-v6. There's more to tell about Windows and IPv6. Before Vista, this was actually how the stack looks like. We had an IP4 stack and we had an IPv6 stack. There were two different stacks, two different protocols. What they did when we went out down to Windows Vista, they have the next generation. You probably went to sessions a few years ago for the next generation networking. That's one of the things they changed. They actually has made one stack for two protocols. They just insert IPv6 in there. So don't think you can disable IPv6. It's not impossible. Only impossible if you go down to the operating system and start rewriting the operating system. Else it's not possible. I will go in that because there are a lot of blogs on the internet how to disable IPv6. There's also could be called how to ruin my computer. Is another word. Okay, what did Microsoft say? He said, hey, at Microsoft they said, well, that's nice, but if I use your MAC address, I got a lot of information about your computer. Because the process you see, it's not some difficult process. You could easily reverse engineer it. Just go do the steps back, you actually easily can find out. So if I know your MAC address, I know which card you have. And maybe, if it's for some laptop, I maybe even can guess what kind of laptop you have. So there's a lot of information. I'm a hacker, and I know which network card you have, and I know probably maybe what for computer you have. That's a lot of information. You don't want any hacker to know that. So they said, hey, and the next thing I can do, if I use your MAC address, well, look at me, I've been to the United States here. So somebody is following me and says, hey, I see this MAC address, it's in Holland now. Now it's on the airport in Schiphol. Now it's on the airport in Atlanta. Now it's in a hotel in Atlanta. I think that person is traveling. Let's send him some traveling advertising. That would be scary. They actually can follow me around the world. I don't want that. So they say, let's change this. And what you will see in Windows 7, it's actually a random IP address. And they give out two addresses. A random normal lifetime, what you have set on your router. You can say, okay, the lifetime of this prefix is, just like we did with the HTTP, how long is the number valid, and when do you have to go for a renew. And what they call a relative shorter lifetime. Actually, in RFC, how did I put it down? So you'll find two addresses on your Windows XP, Windows 7, sorry. The normal and the temporary address. Both addresses will be on your Windows 7 box. And what you actually will see, it used most of the time the last number for communication. So you will be pretty hard to follow because you're all the time changing your address. And I will go into some problems. You can run into it later on. Okay. I like to do a small demo. There it is. Okay. What I will do is going to my Edge server here, and I'm going to set up router advertising on my Edge server. Just to show you the steps you can take. The steps I take on this Windows box is actually what you can do in your Cisco or your Juniper or any other router. They are pretty much the same. Just to get you an idea. Before we go there, just down here to my Windows 7. This is my Windows 7 client. And just run an IP config over here. And let's look at it. You see, I just have an FA80 only. I don't have anything else. So this client is still on IP only because it doesn't have any use for this number. At the back end, I will tell you, already have filled in the numbers on my server, so they know IPv6 already. They already use IPv6 communication with a global address. Let's go to my Edge server. I will be honest, I've written down the commands, so I won't make any typos. That makes my life a little bit easier. If you do a demo, if you do it live and you make typos, it's a bit of a pain. The first commander is net-h, and in use netshell. I will go to netshell interface IPv6 show interfaces. If you want to do router advertising, and my router is also an edge router, I don't want to advertise to the internet. I don't want to tell them which are my internal VLANs. I don't want to give anybody on the internet a free IP number. I want to be hiding from the internet. So it's very important to know which interfaces do I use. And interface 80 is my internal interface. The next command I will use is actually saying advertising is enabled. I will start enabling advertising on that interface. And then I will say, okay, I will publish the route. I say, listen, this is your subnet. You're on that subnet. The route to that subnet is this prefix. Publishing yes. And then you see little translation. I actually start also pronouncing the default gateway. With IP4, you actually can set them a routing environment without using default gateways, only routing tables. In IPv6 world, it's always like, okay, you always have a default gateway for your router. So your router knows only the subnets on your company website, on your company site, on your company, and the rest he will direct to the route of your ISP. ISP always will give you two numbers. One number is for you, and the second number is his router. So let's start in this number. This first one I will show you. Oh, I'll pass it here. And you see a lot of interfaces here. The Teredo and Istatap, I will go in them, how to disable them later on. But they are here already, and we see two interfaces, corp.contoso.com, which is 18, which is my internal, and contoso.com, which is my external interface. And these names I find here. this name here, is actually how I named my network interface. So it also could be internal, external. If you go to the network properties and you say rename it, this is the name you find there. I like to work with numbers because I'm lazy. So let's copy this part and put it there. Okay, commands are in. Let's go back to our Windows 7 and run ipconfig again. And look here, I got now a few global IP addresses. Okay, there's one thing always strange here is that because I'm doing it, I get the link address from my router and not his global address. Routers will hand out his link address. Because I'm on the link, it's okay, I can use this address. Let's do an ipconfig/all, and look what I'm missing. Because I'm missing some very important information. I use Active Directory, and Active Directory use DNS, and I'm missing DNS here. I don't know my DNS server. So to disable IP4 now, my host probably would have a lot of problems with logging on and all that kind of stuff. So I have to do a little bit more. And for this, I have to do two things. First, I'm going to set what we call other stateful of information. Means I'm actually going to tell my router that he has to tell the client that for other information, he has to go to the DHCP server. And this is actually what you can do in all routers. There probably with some thing or bottom or command where you enable this. So let's put in this command also. And let's go to my domain controller. There it is. Where I have enabled. So. And this is all I do on the IPv6 server. There's a lot of information there. And I do a lot of implementations. And if you talk about implementing, people say, oh, we have this DHCP server, and you want to make it high available. So they go do 50-50 or 80-20 or build a cluster or with IPv6, I just can say, okay, just put up like 3 servers which hand out this information. They don't buy it, they don't keep any information, they're just handing out. It's like an information locator we can go to and say, oh, give me the information. Oh, I can make 5 or 6. So high availability of this is very easy. Just put up multiple DHCP6 servers. Okay, let's go back to my Windows 7. Actually looks if it's all working. And there you actually see I got, oh, up here, yeah. Here I got the number and the search list. Both in there. So now I know the IPv6 number of my DNS server, and I know what my suffix is, so I can go doing Active Directory. I put down the commands for you in the slides, so you can, if you download the slides, and I put some extra information at the bottom somewhere and there, so look in the slides, there are a lot of information in it. Let's go on to the next level. I've checked my operating systems, I have set up my routing, so I can do routing, and I can go probably on the internet and do IPv6 on the internet, so that's pretty much set up. But let's look at the applications level. And in this demo, I will go into 2 applications deeply like IS7 and Exchange, just as an example. I will not go through all like IPv6 settings in Exchange and IS, but just show you, okay, where do you have to look and how do you go doing your business. Okay, when they start out designing IPv6, they say, oh, it's not that hard to migrate. It's only the network layer. You've got the OC layers, and it's only the network layer. I see somebody laughing. And he's right. It's definitely not only the network layer. It goes all the way up. You probably have problems on the transport layer where you can't build a socket with IPv6. Sessions based on IP number that use IP numbers to keep up the session. Well, they have to do it on IPv6 now. Or even worse, IP numbers in the applications. I've seen that actually been Perhaps you have to put down IP numbers inside the application. So, in theory, only the network layer. In real life, and that's where we are, there are a lot of more issues. The sockets will give you problems. Log files, if you go to log files, also really nice things. Log files probably, if you have a log file that only monitor the first 2 bits of your IP address, the first 22 bits, and I get the first 48 are everywhere the same. So I only see the first 32 bits, they're always the same. So it is one host that is in the log files. That probably doesn't give me the information I need. Or they actually design maybe an IP4 field, because it makes handy. Security. A lot of products you can block based on IP numbers. Yeah, now we have to be able to block based on IPv6 numbers. If you go to II6 on Windows 2003, and you say, I've got a web server here, and let's give the server an IPv6 number, which we can do in Windows 2003. Hey, that's okay. And you see, I actually can browse to that server based on IPv6. That's okay. But I want to start blocking based on IPv6. It's not possible. So that's things you will run into. So if you look at Internet Information Server 7, and there's a lot of information on the internet around it about IPv6 and this version. And we actually see you can do an HTTP binding, an HTTPS binding, making an IPv6 binding. You can do IP address and domain restriction. If you go into the log files, it actually shows the complete number and not a part of it. And if you download the 7.5 FTP server, you actually can do FTP over IPv6. Exchange also the same story. If you go to the Exchange technical guides on TechEd, they have a whole bunch about IPv6. And I will go into here because there is a lot of talk about that Exchange doesn't work with IPv6. I see a lot of Exchange people saying, IPv6 sucks because my Exchange server doesn't work. And, well, if I go to the website, I get this list of features that work. Oh, it says IP allow list, IP block list works. I can block based on IP. Sender ID, it works. Receive connectors, so I can receive my mail over IPv6. I can send mail out over IPv6. And even a high availability for our Exchange works with IPv6. And it's also nice to tell us what doesn't work. And the first thing, IP allow list provider and IP block list provider doesn't work. And there's a very, very simple reason for this. There aren't any for IPv6. So, well, it's hard then to make it work. So I think we will have a whole moment that IPv6 start kicking in. Somebody in the spam world actually start to figure out, hey, a lot of people using IPv6, and they don't block me because they don't know how to block me. And we will see that spam is coming over IPv6, and then some provider probably will pick that up. So keep in mind, that will happen somewhere in the future. Some smart spammer will find this out. Standard reputation doesn't work for IPv6. Incoming message rates limits. I put it here. I could put it on the other slide also. Partially works. It means it only works for global IPv6 address. So if you have a message attack from a host that has FA80, it will not be stopped. But there's a host on your LAN, on your internal network. But if it's most of the time, it's somebody from the internet that will attack you with a message attack. So that's okay. And one thing that doesn't work, and that's thing you really have to keep in mind, unified messaging. The whole unified messaging part of Exchange doesn't work on IPv6. So if you use unified messaging, you make sure it's really use IP4. Okay, what I'd like to show you is the steps you probably will go through if you do a migration. So, just to give you some idea how that works. Let's go to my Windows 7 box. I'm already in it. And start up Internet Explorer. And we got an external website. Okay, ask me this later, please. That's called Contoso. It's my external, www.contoso.com. This is my external website. And I decided to start implementing IPv6 for this website and to host it. So I'll probably go to my ISP and say, listen, ISP, I got this website that you're hosting for me, and I want IPv6 for this website. So probably the first step you will go through is testing. And how do you go testing if it actually works for IPv6? Oh, well, let's go to, I don't need you. Let's go through my ISP, and there we got the DNS server, my external DNS server. The ISP probably will go do the first thing. He will probably open his network and start changing the adapter settings and say, okay, you like to have an IP number for your IPv6 number. Okay, I will go through my list of IP numbers, and he will hand out an IP number and add it to his web server. Oh, I forget one. Okay. There's probably something like this he will do. He will have some way of giving out the names, and he say, okay, your customer number and something like that. He will put it in here. That's the first step he will do. The second step he probably will do is, okay, he's going to the DNS server and say, before we start going completely live, let's make a test website. What I see a lot of websites doing is www.6. I mean, okay, this is our 6 website for testing purpose. And that's a good way to start with it. And, well, let's make a Crop.A record. And let's skip this. Here you see Windows DNS automatically detects it's an IPv6 number and makes automatically the correct number. Okay. The last step is actually starting making the binding. Let's go to bindings. Let's say add, and here I will again actually choose the new number. I'm making a typo, sorry. Yes, here it is. Okay. I actually don't have to do this. I don't have to use host headers anymore. Host headers were invented because we didn't have enough IPv4 numbers. So on one IPv4 number, you want to run multiple websites, and they invented host headers. Well, I have enough numbers, so I don't actually need to enter a host header here, but I like to do it anyway. Let's start testing. Let's go to my Windows 7. And let's put 6 here and look what's happening. Okay, it's the same website. It was the same website. Get the same website. And look in here. And actually you see I got a connection based on an IPv6 number. Here. Connected to the website. So it's actually connecting over IPv6, and I can do the testing on the website. And in my case, my website is very easy. It works. So I can go to my ISP, and the last thing he probably will do is, again, going to his DNS server, make a new record, and again the number. I say it works, so please make the website live on IPv6. 1969. And he will make the second binding also on his IS server. We will add this number also. I think contoso.com here. So this is basically what will happen with the IPv6. So now my website is migrated to IPv6. I first have tested on the test website, it works, and then I go all the way down to IPv6 natively. It's now dual stack, what I say. I'm now in a dual stack node for my website. It got 2 bindings. And you actually can get a certification for this. The same website, the IP6radio.org website, actually gives out emblems, logos you can put on your website if you run IPv6. Okay, let's start talking about problems, because there are problems is the most things people are afraid of. you will run into problems. That's for sure. What I see, what I explain is this. In a lot of blogs, start disabling IPv6. You know, they go into the registry and they say, well, just punch down these numbers and you won't have IPv6 enabled anymore. Very good. And a lot of things get broken. I will give you a few. Hyper-V cluster. You can't add a node anymore. Very good. You can't scale out anymore. TMG server. It doesn't support IPv6, but if you then disabled, VPN won't work on it anymore. Routing remote access server actually breaks if you disable IPv6, if you do this. Exchange, things I've seen actually doing, because I do a lot of exchange jobs, and I went to customer sites and they disabled with this register key IPv6, and then mail flow problems. Sometimes it arrives, sometimes it don't. That's strange things. Or they try to add an extra server and they fail because IPv6 was disabled. What about direct access? I don't think I have to go in there, but if you disable IPv6, direct access definitely won't work. And the last thing is not really something we do in our job day-to-day life, but everybody heard about home group on Windows 7? You know it needs IPv6. It's based on IPv6, so if you disable IPv6, home group won't work. That's a fun thing. People start disabling for their friends. IPv6, you don't need it. Let's disable it on your workstation, on your computers at home. And then home group, which is pretty nice, doesn't work. So you will run a lot of issues. And I just name a few I could find, and I've experienced myself by people actually disabling IPv6. And you will run into more problems. So don't disable it. What you should do is start implementing it. Start thinking about it. Start making a design. Start checking your devices if it's ready. Start testing and running dual stack. That's the way to go. Don't disable IPv6. And what if there is no solution? You will run in some moment when you say, okay, I actually have no solution for this. Like firewalls. A lot of firewalls are not really supporting IPv6 or a little bit. It's still a major issue. I found that there are a lot of big firewalls who support IPv6, but not completely like they do in IP4, or you know, they support it, but there are a lot of holes in it, so that makes it hard. What if you can't build an IPv6 socket? You say the application doesn't allow me to build an IPv6 socket. Or what if anything goes wrong with logging? You are in dual stack mode. You have to make sure that you force the use of IP4 in that moment. It means you're going to look at your name resolution. So if I do a ping for a name, I will get back an IP4 number and not an IPv6 number. Or maybe you just punch in the IP4 number. I don't like it. I'd rather go with full qualified domain names, but maybe that's a solution for you. I would like to go into a demo where I actually start showing this on the TMG. TMG doesn't support IPv6. Well, it does. It blocks it completely. That's good news. ISA doesn't understand IPv6 at all and just let it pass through. So TMG does understand it and blocks it completely. And some strange things, actually what I show here on TMG can happen also with client antivirus. There's an antivirus product with firewalls in it on your client installed, can have some same issues what I show you here. So what I do, I'm going to set up something because I want to sniff some out of the network. So I'm first going to punch in some commando, set some things, and then I will go through everything again and show you what I have done. The first thing I will go is to my TMG and open command prompt. Yeah, open command prompt. Okay, I probably get 8 command prompts now. Yeah, what did I say? It always happens. You know, that's why I have no patience. I should click and wait, but I'm, hey, give me the command prompt. So let's close this one. I knew this would happen. And what I will put in is ping nail.corp.contoso.com, which is on my Exchange server. I will not press enter now because I want to do some sniffing later on. So I want to make the amount of package I sniff at least as possible. I run the same commando on my Windows 7 box, and I will start sniffing on my domain controller. Here it is. Let's disable this ISO tab. I don't want to run a capture on ISO tab. You start running. Okay, and now I'm going to my TMG. I hit enter here. That goes wrong. I do the same on my Windows 7 box. That goes correct, and then I stop the sniffing. And let's look what happened. Just to set up the demo. Okay, this probably you've seen you are in TMG, your daily day work. You just drink your coffee, it's morning. People are complaining, mail is not working. And the first thing you do, you go to your TMG and start pinging mail.corp.contoso.com. And it says, you probably made a typo. I made a typo. You look at it, no, I didn't make a typo. The first thing I probably would do is then go back to my desktop. I probably have a remote desktop session into my TMG. So I will go to my desktop and actually hit the same commando. And I actually get a reply, an IPv6 reply. Okay, let's go into deep what's actually happening here. So let's go down and find the DNS. Here we got the DNS. 240 is the number of my TMG. And here I see the first request. TMG asking a DNS request. And what does he ask for? I want to go a little bit down here. It asks for, I want to open this one, and here we see it. It asks for an A record. He said, give me the A record of mail.corp.contoso.com. And the answer is, sorry, I don't have it. It actually doesn't return an address. You can see it in here. Oh, sorry, I hit some button. It actually doesn't give back an IP address. Let's continue down and look for the second. Here's my XP workstation coming, or my Windows 7 workstation coming. It starts to asking the same question, but here we see like 4 package. You see 4 package. And the first one is the same as a TMG. It asks for an A package. Give me the A record. If we go to the second request, here we see Quattro A record. So what actually happened, my TMG never asked for a Quattro A record. It's been stopped by the firewall software on the TMG. They completely blocked this request. And this actually can happen with client firewalling. They stop the request, so if you try to go to an IPv6 address, you fail. And you can run into issues here because you're trying to go over IPv6. The solution in this case is, because I use TMG as my firewall, would be making a correct A record and use an IP4 number. The next thing is very, very strange. They have stopped the Microsoft. I found that the random IP addressing a very good idea. The first thing I heard about is, oh, that's a good idea. You know, nobody can track me. But you can run problems. Let's go back to IP4 and look how IP4 actually goes with his number. The moment my client boots, and it's on a familiar network, on my corporate network, it will go to the HTTP server and ask for a number, and probably gets the same number you had yesterday, and the day before, and the day before that. If you have not enough numbers, then it will change. But if you like, most of us probably will give away more numbers than hosts you have. So actually, the client will get an IP number that he had yesterday, the day before, and the day before that. And a lot of systems actually use this fact and say, okay, the client always has the same number. So let's build a session based on his number. So they build a session, and because my number is the same, the session stays up and nothing goes wrong. And then we go to IPv6, and the number is changing every 4 days, and sessions get broken or smarter. Things like you get in the hotel and you get, well, I'm staying in a hotel now, and if I open my laptop, I authenticate it on Monday. On Sunday, I went to the hotel, opened my laptop, and did my authentication on the website there. And now every time I open my laptop, I can go in the internet because he knows my IP number and he knows my MAC address. Okay, you're the same. It's the same guy from yesterday. You have logged in already. He keeps some session. If you use IPv6, I probably have to log in every time I have to boot my computer because my IP number changes all the time. This actually can give some problems today. And there are actually some people complaining, especially with routing. People have connected to router for monitoring and that kind of stuff. The fun part, and I will show it later on, these temporary addresses also are back on my service. If I go to my domain control later on, I will show you it on my Exchange server. I actually have a second address there, which I didn't give. So I give it a static IP address, and it makes a second one up. Another thing that has got a lot of issues are those tunnel interfaces. If you do ipconfig on a Windows workstation, you lots of IP tunnel interfaces. So people start disabling IPv6 because they want to get rid of all those interfaces. And there actually is to say something about it. I set up, okay, it only works internal, so that's not really a problem. And 64 only works if I have a global IP address. So let's go to university. Most universities use global IP addresses. So if I would open my laptop, and they have this nice firewall setting there, and they protect me against most attacks, and they make sure I can't do anything bad, and then my workstation is making a tunnel through that firewall all the way down to the internet, based on IPv6. There goes the security. I don't want that. So maybe a good firewall admin will disable it, but if he doesn't, it actually can go on the internet. Same for Teredo. If Teredo is enabled, there's a big chance that my host is actually going to make an IPv6 tunnel to a Teredo server external. Again, blowing a hole in the firewall. And people can go back over that tunnel to my workstation and go and attacking computers, attack my workstation, and from there, attacking other computers. So you probably want to disable this. There's well one thing you have to know. If you start disabling these interfaces, you also disable part of direct access because direct access uses this interface. So be careful. If you're using direct access, don't start disabling them. The other solution for these tunnel interfaces is going to your firewall and just start blocking them. That's the best thing you can do. Because keep in mind, you probably can disable it for all your managed PC. But let's say I'm visiting you for one reason, and I didn't disable it on my PC, I will build a tunnel. So the best thing is disable it on the firewall. I will show you how to disable it on your how you can disable it on the workstation. Let's go back to the demo environment. Okay. A few things I'd like to show you. Let's run ipconfig here. You probably have seen these numbers. We've seen these numbers on their workstation. Yeah, you've seen them. This is a Teredo interface. And Teredo always starts with 2002, then do some funny stuff with your IP number, and then do that again. And because I have multiple IP4 numbers, it does it twice. I don't have internet connection, so my 64 tunnel is on top. But this is my ISP, and my ISP uses global routable IP addresses. And this web server actually could make a tunnel all the way up to internet now, to some server over there. And think, actually, my firewall is no longer protecting my web server anymore. Maybe traffic is going to be routed through the tunnel. So all things can happen here. So you probably want to disable it. Let's go to my domain controller and do an ipconfig there. it actually has a second IP address. Because I enable route advertising, it makes a second IP address and a randomized IP address. I have no clue. And this IP address is changing all the time. And I got a big chance my domain controller starts using this IP address to communicate. Now, that's pretty scary. So these things you probably want to disable, especially on your service. I've set it up for my Windows 7 just for the demo purpose. And let's go to the commands for doing this. And let's go over the commands. Again, it's on net shell commands I use. And the first one, I don't go into the registry. You will see the people going to the registry. You don't have to go into the registry. You can do it from net shell. And this is easy because you're going to run a script. The commands I put here, you can put it in a script and run the script anyway. The first is actually saying global randomizer disable. I disable the randomizing option. The second is the template IPv6 address. The second address you're always using, I disable it. Those two commands actually disable the whole randomization and it uses a process where I use my MAC address, put this on FFE, flip a bit, and make a host ID. Then I can disable iSetup, Trado, and 624. Okay. Let's do the first two. Let's run in PyKey/all. Okay, what you see here is that it actually keeps the old two addresses. I need to reboot the computer actually to get the temporary address completely away. But what I would really like to show you what's happened now is this is my MAC address. And here we see 15. Here we see 5D. Here we see those FFFE I was talking about. F5, C0, and CD. You actually see the MAC address back in here. So it actually makes a number on the MAC address. For the other two, I can actually read and reboot, and I will not go there now. Okay, let's start. See, there's one typo here, so let's put it in. Oh, yeah. Let's start and disable these interfaces. And let's do an ipconfig. Okay, well, let's do an ipconfig. This gives me less information. And now I got pretty much a clean ipconfig. It's only one interface. But I could use an IP4. But keep in mind, if I start using direct access, that breaks now. This client is no longer ready for direct access anymore. Okay, there's one last thing you can do, actually, but that's, then you're really going, well, I think, going to Device Manager, show hidden devices, and here we've got an iSetup adapter. You actually can go disable the adapter itself. So you can run the commands on show, and you can go here and start disabling the adapters itself. Here you've got the iSetup adapter, and if you say right block disable, you disable iSetup also. So there's two ways you can go around doing this. I start out by telling that there are like 5 steps you can go to IPv6. And the first step is designing, and keep it simple, guys. If you start designing an IPv6 environment, keep it simple and keep it easy, because IPv6 is pretty complex because it's a big number, so make them small and make them readable for yourself. If you go starting migrating your operating system, don't forget to go to IPv6ready.org and to check them out, and do that same for all your network devices like Cisco, Juniper, or whatever you're running. And then check out your applications. And with applications, go look at especially every place there's an IPv6 number. Okay, and if you run into problems, there are a few things. You are in dual stack mode, so always start checking, okay, does I need an IP4 number for this communication, or do I need an IPv6 address for this communication? Or does it matter? Go check for these things. But keep in mind, if you start working with IPv6, it's IP4 with 128 bits. I wrote them on the zeros. It's just more zeros, that's all. It's just a bunch of zeros, that's it. Now don't be afraid. It's not like, okay, it's not rocket science or very difficult. It's just IP4. You know, if you know IP4, a lot of knowledge you have from IP4. TCP is still TCP in IPv6. And UDP is still UDP in IPv6. It doesn't change. Yes? If you use IPsec now, it's the same in IPv6. If you make access lists on your route, you say block AD, it's the same for IPv6. Only the number is getting bigger. And if you like, you can read it out on the right. That is actually standing out how to pronounce the number. So if you must do some impression tonight at the party, remember this and then say, there are 315 undecillion, 282 decillion, 366 nonzillion, and they're probably like, okay, you are very good. Okay, I got some minutes left, so time for Q&A. I don't know if anyone has a question. So please stand up, go to the mic, and if you have any questions, please stand up, and have a nice day. Thank you. Don't forget to write your evaluation. And they told me if you use this, you actually can find my track very easy. Thank you.